where to write the wave function. Okay, so let me continue that. So in the case of hydrogen atom, if you solve the electronic Schrodinger equation, that is H electronic psi electronic equal to electronic energy into psi electronic. So if we solve the Schrodinger equation, we get solution as wave function and we get the energy eigenvalue. Okay, and I told you last class that this wave function, that is electronic wave function, I'm not going to put E here, okay, but keep this in mind, this is actually electronic wave function. This electronic wave function depends on three variables R, theta and phi. Okay, electronic wave function depends on three variables. We can separate this total wave function. Total means wave function depends on R, theta, phi is called total wave function. I'm going to separate this total wave function into two parts. One depends on radius alone. Okay, it is called the radial part of the wave function. The other one depends on angular part, theta and phi. So we can separate the total wave function, that is electronic wave function, into two parts, radial part of the wave function and the angular part of the wave function. Okay, then in the last class I gave the general expression for the radial part of the wave function. What is the general expression? Radial part of the wave function is equal to some constant k into r power l into a polynomial, and the degree of the polynomial is n minus l minus 1. Okay, degree of the polynomial is n minus l minus 1. Then you will be having an exponential term e power minus r by principal quantum number n into a naught. A naught is the Bohr radius. Okay, this is the general expression for the radial part of the wave function. And remember, radial part of the wave function depends on two quantum numbers n and l. Radial part depends on two quantum number n and l. Okay, this is the general expression. And last class I gave the radial part of the wave function for some simple cases. Yes.
Sir, and the radial node எழுதிருக்கீங்களா sir for?
Now listen. So first I'll write radial part of the wave function. Okay, radial part of the wave function for 1s orbital. In hydrogen atom, if you solve the Schrodinger equation, you will get wave function for 1s orbital, wave function for 2s, 2p, 2px, 2py, 2pz. Okay, all wave function we get. Now what is the radial part of the wave function for 1s orbital? How to get that? Listen. For 1s, you know very well, n value is 1. For s orbital, L value is 0. You know very well. Correct. Now substitute this value here. K into, if I put L equals 0 here, R power 0 is 1. So you need not write that. Then you have a polynomial. What is the degree of the polynomial? N minus L minus 1. Correct. N value is 1. L value is 0. So 1 minus 0 minus 1. What will get? 1 minus 0 minus 1. Enna varum?
0.
You will get 0. Okay. If you get degree 0, that means you will be having only some constant here. The polynomial is a constant. You will get some constant a. Okay. Then into e power minus r by principal quantum number is 1 here. So 1 into a naught, that is a naught. Okay. This is the radial part of the wave function for 1s orbital. And if you plot this wave function, I'll observe pannunga. If you plot this wave function, that is the radial part of the wave function for 1s orbital in y-axis and radius in x-axis. Okay. Here r equal to 0, r can go up to infinity. observe this carefully. R equal to 0 means center of the nucleus or at the nucleus. R equal to infinity means the electron is far away from the nucleus. That's the meaning. Okay. Now, if I put R equal to 0 here, because we have only R in this expression, in this exponential term, if I put R equal to 0 here, I'll get e power 0. E power 0 is 1. 1 into some constant is there. Okay. So 1 into some constant, you'll get some constant. So at R equal to 0, the wave function has some value, some constant value. As R increases, see, as R increases, the function will decrease exponentially. Minus is there, therefore the function will decrease. So the function decreases exponentially, and the wave function never becomes 0. Okay, in between R equal to 0 and R equal to infinity. Between R equal to 0 and R equal to infinity, the wave function never becomes 0 at any place. That means there is no radial node. There is no radial node. No radial node for 1s orbital. Okay, that is another important point you should keep in mind. Now, if I plot probability, probability means take the square of the wave function. Take the square of the wave function for 1s orbital. Okay, I am taking square. Then plot that versus radius. R square will give you probability. Now I am plotting just to probability versus R. Okay, if I take square of this, I'll get k square. K square anyway is a constant. I'll get a square, that is also a constant. Then if I take square of this, I'll get e power minus 2r by a naught. If I take square of this, you'll get e power minus 2r by a naught. Anyway, that function also behave like your radial function. What does this indicate? It indicates that this is probability. So probability is maximum. See here, probability decreases, correct? Probability decreases. Probability is maximum at R equal to 0. At the place R equal to 0, that means at the nucleus. At the nucleus, probability of finding electron is high. Okay, is it correct or not? Is this correct?
Yes, sir.
Listen,
Yes, sir.
whatever function I have given, it's correct. Is the concept correct? At R equal to 0, okay, you are getting maximum electron density. R equal to 0 means at the nucleus. Is electron present in the nucleus?
No, sir.
No. So that means this.
No, sir.
So something is wrong in this probability curve. Okay. Actually, we have to plot radial probability. This is just probability. Okay. What is the radial probability? Let me do it in the next page. Radial probability. To get radial probability, you have to multiply this probability by the surface area of the sphere. 4 pi r square is the formula for surface area. So surface area of the sphere into probability of the wave function r square. Now take this product, take this entire quantity and plot this versus r. Okay, this is called radial probability plot. Also called radial probability distribution. We can say in the other way. Distribution. If you plot this, listen, at r equal to 0, if you put r equal to 0 here, the entire term becomes 0. So the wave function or this quantity becomes 0 at r equal to 0. Now as r increases, listen, as r increases, we have r square term here. So initially the wave function will increase or the probability will increase. It reaches a maximum. Then as r increases further and further and further, the r square term has an exponential part. So the probability will start to decrease. Okay, so the probability plot looks like this. What does this indicate? It indicates that probability is maximum not at the nucleus, at some place. Okay, we call this as RMP. What is RMP? It is the distance where most probable position of electron, or we can say the other way, it is the probability of finding the electron Okay, the maximum probability of finding the electron, right, away from the nucleus. Okay, at this distance, probability of finding electron is maximum. That's the meaning. Okay, or I can say R max also, or MP or R max. What is R max? Maximum probability of electron exists at this distance from the nucleus. Okay, is this clear? Any doubt? Any doubt up to this?
No, sir.
Okay, right. So I have discussed how to carry out radial just wave function and probability plot, then radial probability plot. Radial probability. This is what important for us. Okay. Now, in a similar manner, let us take 2s orbital. Radial wave function for 2s orbital. How does this look like? 2s means n value 2. For s orbital, L value is 0. So what's the value of n minus L minus 1? Anyone? N minus L minus 1?
1, sir.
Equal to 1, right?
1, sir.
1. So now, how does this wave function look like? In the wave function, some constant k into r power L value is 1. Sorry, L value is 0. So r power 0 is 1. So I'll put 1 here. Into n minus L minus 1 is 1. That means degree of the polynomial is 1. Degree of the polynomial 1. Meaning? What's the meaning? The meaning is you take some constant, multiply this with r plus another constant b. So this is actually a polynomial. Here r power 1 indicate degree. So degree of this polynomial is 1. Whenever degree is 1, you have to write the polynomial in this manner, a into r plus b. Then we have an exponential term, e power minus r by principal quantum number is 2, so 2a naught. Clear? This is the radial part of the wave function for 2s orbital. Okay, if I plot this wave function, hello? Yeah. If I plot this wave function, 2s orbital wave function versus r, how does this wave function look like? Here I have an r term here. I have an r term here and I have another r term here, correct? So as listen, when I put r equal to 0, if I put r equal to 0, here r is 0. If I put r equal to 0, this becomes 0, but we have b here. If I put r equal to 0, e power 0 is 1, so you will get some value. It does not become 0, you will get some value. So at r equal to 0, you will get some value. Then as r increases, what will happen? We have exponential term here, so it will decrease, and at one stage, if r is equal to, suppose if r equal to minus b by a, what will happen? If I put r equal to minus b by a, what will happen? Can anyone tell me? In the place of r, if I put minus b by a, what will I get?
Minus b.
Minus b plus b become
0.
0. So the wave function becomes 0. Yes, wave function becomes 0, right, when r is equal to minus b by a. So listen, if wave function becomes 0, we call that point as a node. Okay, then as r increases further, what will happen? It goes to the negative side and goes to the 0, it approaches 0 as r become infinity. So the wave function will look like this. Okay, now between 0 and infinity, the wave function becomes 0, or the radial part of the wave function becomes 0 at one point. That is called a node. So for 2s orbital, we have one radial node. If radial part of the wave function becomes 0, it is called radial node. Okay, then what happens if we make a probability plot? Probability means take the square of this and then plot. Take the square of this wave function and then plot. If you take square, listen, what will happen if you take square? The probability will decrease, become 0. Then it never goes to negative side because you are taking square. It never goes to negative side. Instead, it goes like this. It goes like this, then it goes like this. Okay, the function will go in this manner. No, 1 second. I made a mistake. I'm sorry. If we take the probability, yeah, correct. So this is how the probability plot will look like. See, here also the probability is maximum at r equal to 0. That is wrong actually. Okay, this one is wrong. So we have to go for radial probability. Radial probability curve, you know very well how to do that. Radial probability வேணும்னா 4 pi r square ஆல மல்டிப்ளை பண்ணனும். So you multiply 4 pi r square, that is surface area of the sphere, into radial part of the wave function, take the square for 2s orbital. Then plot this quantity versus r. If you plot this, listen, now we have r here. So if I put r equal to 0, the entire quantity becomes 0. If r equal to 0, the entire quantity becomes 0. As r increases, it increases initially and becomes 0 at node. Then again it increases, reaches a maximum, then it goes to 0 as r approaches infinity. Okay, so here we have a node and we'll get a maximum at some distance. So this is the r max for the 2s orbital. So the point is this, listen, if you take the radial probability plot, நல்லா observe பண்ணுங்க, for 1s orbital I will get only one maxima. For 1s orbital we will get one maxima. For 2s orbital the radial probability curve has two maxima and one node. If you go to 3s orbital, can anyone tell me how the radial wave function look like for 3s orbital?
3 maxima and 2 nodes.
Yes, you'll get 3 maxima and 2 node, correct? Now listen, what is the, okay, here n equal to 3, for s orbital l equal to 0, so what's the value of n minus l minus 1, anyone?
2.
2, that means
sir.
the polynomial degree is 2. So how does that polynomial look like? Some constant k, r power l value 0, r power 0 is 1. Then how does the polynomial look like, anyone? Degree is 2. So a into r square, very good, plus b into r plus c. This is the polynomial where a, b, c, these are all constants. Okay, highest power of r is 2, that indicates degree. Okay, into e power minus r by n value is 3 here, so 3 into a naught. This is the radial part of the wave function for 3s orbital. Is this clear? Any doubt? Now here one thing is very important. As far as s orbital is concerned, okay, for ns orbital or ns subshell, for any s orbital, okay, number of radial node, how many radial node? Number of radial node is equal to, yeah, general formula is this, n minus 1. This is the number of radial node formula for any ns orbital. Okay, if you take 1s orbital, n value is 1. If you put 1 here, 1 minus 1 is 0, so no node. For 1s orbital, no node. For 2s orbital, you will get 1 node. For 3s orbital, you will get 2 node. For 4s orbital, you will get 3 node, like that. For ns orbital, you will get number of radial node equal to n minus 1. Okay, now what about for p subshells or p orbitals? Okay, let me go to the next one. Suppose I'll take radial part of the wave function for 2p subshell for any 2p, that is 2px, 2py, 2pz, for any 2p orbital, radial part is same. Okay, whether it is x or y or z, don't worry about that. For any 2p orbital, the radial part is same. So I'll write the radial part first. So how does the radial part look like? N value is 2 here. For p orbital, L value is 1. So what is the value of n minus L minus 1 in this case?
No,
Zero, sir.
In this case, it is 0. Therefore, how does the wave function look like? Radial part of the wave function? K into L equal to 1. So, we have R. R power 1 should be there. Okay. R. Then, what about the polynomial? Degree is 0. That means there should be a
Power 0, 1.
yeah, there should be a constant, correct? Degree 0 means there should be a constant. Then e power
minus 2r by a naught.
minus r by
Sorry,
n value is to 2a naught, correct?
2.
Is this correct? Yeah, this is the radial part.
Yes, sir.
Yes, this is the radial part. That's all. So in this manner, you can write the radial part of the wave function for any orbital. Any orbital you can write. Okay, this is the idea. Right? Now, tell me number of nodes for 2p. How many nodes are there? Listen, if you want number of node, if wave function is given, if they ask number of radial node, what we should do? Very simple, make this wave function 0, that's all. Okay, put this value equal to 0, k into r into a into e power minus r by 2a naught. Put this value equal to 0, that's all. Okay, now see, k is a constant, a is a constant. If you bring k, a, everything this side, it becomes 0. So r into e power minus r by 2 into a naught is equal to 0. Now if I multiply these two, I will get 0. That means either this should be 0 or this should be 0, correct? So there are two possibilities. One is r equal to 0. The other one is, if this is 0, when this will become 0? Can anyone tell me when this will become 0?
Infinity, sir.
Listen.
I think
So what about the angular part of the wave function y theta phi? That is spherical harmonic part. Before going to see this is very important. We write, see, if I represent a point using x, y, z value, it is called Cartesian coordinate. We can also represent a point in spherical polar coordinate using the coordinate r, theta and phi. X, y, z represent Cartesian coordinates. R, theta, phi, these are all spherical polar coordinate. Now what is the relation between these two? Remember this relation. X is equal to r sin theta cos phi. Y is equal to r sin theta sin phi. And z is equal to r cos theta. Note down, this is the relationship between Cartesian coordinates and spherical polar coordinates. Clear? What is the meaning for r, what is the meaning for theta, and what is the meaning for phi? Listen, suppose I will take a Cartesian coordinate space. Okay, let me take this axis as perpendicular axis. So this is x axis plus x. Okay, this is plus y. This is minus x. This is minus y. This is plus z axis and this is minus z axis. Okay, see, the x axis is perpendicular to the paper. Keep this in mind. X axis is perpendicular to the paper. Now I will take some point in space. Say I'll take some point here. Okay, now I'll join this point to the origin. Distance between origin and the point P, okay, that distance is nothing but r. So what is r? R is the distance between the origin and the point. Then what about theta? Theta is nothing but the angle between plus z axis. Angle between plus z axis and the line joining the origin and the point. So this angle. This is theta. Okay. Now, what is phi? You draw a projection of this point to the xy plane. See, what I'm doing? I'm drawing a projection of the point to the xy plane. We get some point in the xy plane. Now join the origin to the point P prime. The angle between plus x-axis and this line, that is the line connecting the origin and the projected point. Okay, this line and the plus x-axis. This angle is nothing but phi angle. So which one is r? Which is theta, and what is the meaning for phi angle? Okay, so keep this in mind, very very important. Now let us discuss our the spherical angular part of the wave function. Okay, just copy down this. Right, for 1s orbital L0 M0, therefore angular part of the wave function is a constant. Okay, whenever L0 M0, angular part should be constant. Keep this in mind. Not only for 1s orbital, for any s orbital, okay, angular part of the wave function is a constant. Okay, for any s orbital, right, angular part of the wave function is constant. Why? Can anyone tell me why? Suppose you take 2s orbital. What's the value of s? L?
L0, sir. S orbital L0.
For any s orbital, L0 M0. If L0 and M0, so the
Spherically symmetric.
the radial, the angular part of the wave function is a constant. Is this clear? Any doubt in this?
No, sir.
Yeah. So keep this point in mind. For any s orbital, angular part of the wave function is constant. Okay. So angular part becomes significant only for 2p orbital, d orbital, f orbital, like that. Okay. So angular part now we focus only on 2p, 3p, or 3d, 4d, like that. Okay. Now let us take wave function, say 2px orbital. 2px orbital. How does the radial part will look like? Can anyone tell me what's the radial part? How the radial part will look like? I'm asking radial part. For radial part, you should take n value. N value is 2. For p orbital, L value is 0. Okay. 1. For radial part, we require n and L. How we write the wave function for radial part? K into L value 0
into
R power 0 is 1.
R1 and L value 0, sir. 1, sir.
I'm sorry. I made a mistake. I am very sorry. Yes. For p orbital, L value is 1. Yeah. So K into R. Then what is the degree?
To A, sir. 0, sir.
Degree is 0. Therefore, some constant A into
e power minus R by
A
minus
n value is
2A0.
2A0. Correct. This is radial part. This we know. Now I am going to focus on angular part. For angular part, we require L value and M value. What's the L value?
1, sir.
L value is 1. Correct. Now listen. I'll observe. L value is 1. L value is 1. Okay. If L value is 1, we'll get 3 possible ML value, right?
Yes, sir.
What are the ML value? Plus 1, 0,
minus 1.
Minus 1.
Minus 1.
Okay. Okay. Now listen. Now you don't worry about this. See the x. Okay. X value. For x value, what is the angular coordinate? Or x is equal to, what is the relation between Cartesian coordinate and
R sin theta cos phi.
R sin theta cos phi. Am I right? Listen, remove this R because this R is already included here. Radial part is included in this equation, so don't worry about the R. you take only this function. What's the function we have? Sin theta.
Sin theta cos.
So angular part is sin theta into cos phi. That's all. Very simple. Now, what is the overall wave function? Can anyone tell me what is the overall wave function? Wave function for 2px orbital. How does it look like? Yes.
K into R
multiply
into
these two. K into. See, this is a
R
constant.
into
This is another constant. Constant into constant become another constant. Okay. It's
constant.
another constant. So let me write this as some constant K1. Some constant. That's all. Then we have R. Then e power minus R by 2a naught. So this is the radial part. Then
sin theta
Sin
cos.
theta cos phi.
then sin theta into cos phi. This is how wave function for 2px orbital look like. It's very simple. Take down. Yes, ML 0 because we have Z orbital. Correct. Okay. Now listen. In your point, note பண்ணிச்சுக்கோங்க. This is very important. If orbital contain pure Z, orbital containing only Z coordinate, then their ML value should be 0. Keep this in mind. It's a very essential point. If orbital contain only Z, see here I have only Z. If you have any orbital having only Z, then ML should be equal to 0. Clear? So, what is the radial part? Radial part is K into, first tell me the NL and ML value. I will write here. N value is 2, L value P orbital, so L value P subshell, L value is 1, Z orbital, so M should be 0. M should be 0. Okay. Now, how to write the radial part? K into R power 1 into what is the degree? N minus L minus 1. What is the degree?
It's 0.
Degree is 0. That means how the polynomial look like? Into
A constant.
into e power minus R by n value is 2, so 2 into a naught. This is the radial part. Radial part. Can anyone tell me what is the angular part?
R cos theta.
Is it?
R cos theta.
R is included here.
Cos
R
theta.
comes in radial
So
part.
cos
So,
theta.
so
Cos theta.
cos theta. That's all. Yes, that's all. Very simple. It's a general way of writing wave function for any orbital. You can easily write. Okay. Now I will teach you one important point here. What is the angular node? How to find out that? Okay. Even for the previous case, I didn't do. I'll do it now. Listen. What is the angular node? Right? Angular node for 2p Z orbital. Angular node for 2p Z orbital. Okay. How to do that? See, it's very simple. You just make angular part of the wave function as 0. Cos theta equal to 0. Can anyone tell me at what theta angle cos theta becomes 0? Anyone? For what theta angle cos theta becomes 0?
90, sir.
Yes? Be louder.
Cos 90, sir.
Cos?
Cos 90, sir.
Cos 90. Correct? So, if theta is equal to pi by 2 is 90. If theta is equal to pi by 2, cos theta becomes 0. Theta pi by 2 எப்போ வரும் சொல்லுங்க? நான் உங்களுக்கு அந்த XYZ ல காமிச்சேன் இல்லையா? Theta pi by 2 என்ன மீனிங்? நான் இங்க டயக்ராம் போட்டு காமிக்கிறேன் so that you will get some clarity. Observe this carefully. Observe this carefully. This is plus x-axis, plus y-axis, minus x-axis, minus y-axis. This is plus z and this is minus z. Okay. Observe this carefully. Okay. Now we are going to draw 2pz orbital. How does 2pz orbital look like? It has two lobes, one along positive z axis, another lobe along negative z axis. Am I right? Okay, 2pz orbital will, has two lobes, one along plus z axis, another one along minus z axis, because 2pz orbital. Right? Now, where is the node? Where is the node? What is the meaning for theta angle?
Origin.
No. What is the meaning for theta angle, ma'am? I will teach you in a clear manner. See, if I make this angular part as 0, you will get angular node. Cos theta 0. Listen, at theta is equal to pi by 2 degree, cos theta becomes 0. Theta pi by 2 means from plus z axis. Theta pi by 2 means it should be in xy plane. So we have a plane in that is xy plane where the angular part of the wave function is 0. Okay, so this plane is called the nodal plane. Nodal plane, and I have only one nodal plane. That means there should be one angular node. For one nodal plane, we have one angular node. Is this clear? Is this clear? So in a similar manner, what is the angular node for 2px orbital? Listen, for 2px orbital, the wave function look like this: some constant k into some another constant a into e power minus r by 2a naught. Okay, I'm sorry, r power 1. Okay, L value is 1, so r power 1. So this is the radial part, and for x, angular part is sin theta cos phi. Correct? This is the total wave function. To find the angular node, what we should do? We should keep this angular part as 0. Sin theta into cos phi equal to 0. Can anyone tell me at what theta value sin theta becomes 0?
0.
0, sin
If
0.
theta is 0 degree, sin 0 is 0. Yes, you're right. And what phi angle? Cos phi is 0.
Pi by 2, sir.
Cos phi equal to pi by 2. Am I right? Is this clear? Theta 0 means?
In Z plane,
No,
along the
listen, if point is present in plus z axis, if point is present on the plus z axis, then theta is 0. Phi pi by 2 means, listen, from plus x axis, right, 90 degree is at plus y, correct? So the plane should be which plane? I repeat.
Z and AY.
I repeat. Exist for px orbital
X axis.
along x-axis, right? So along positive x-axis we have one lobe. Then along negative x-axis we have one lobe. So lobe is present here. Where is this plane?
YZ.
YZ plane.
YZ.
Yes, you are right. At the in YZ plane, okay, along YZ plane, probability of finding electron is 0. Okay, so it is a nodal plane. So how many node is there? How many
One,
nodes?
sir.
One node. One for one nodal plane, one node. That's the meaning. Okay, take two. That's the meaning. Make it fast. Or this formula you might have seen in your lower class itself. Number of angular node is nothing but equal to the value of L. L value will give you number of angular node. For any 2p orbital, 2px, 2py, 2pz, for any 2p orbital, L value is 1. I'm sorry, for any p orbital, not only 2px, 2py, 2pz, even for 3px, 3py, 3pz, 4px, 4py, 4pz, for any p orbital, okay, L value is 1. So number of angular node is 1. You will get one nodal plane. That's the meaning. Now let me go to another orbital so that you will get are you comfortable in this? Okay, so we need to find out the value of x and y, x into y dxy. So what is x into y? X is sin theta cos phi, y is sin theta sin phi. Okay, if I multiply, I will get sin square theta, then sin phi into cos phi. I will multiply this by 2 and I am dividing this by 2, so that the equation remains same. And you know very well 2 sin phi cos phi is nothing but sin 2 phi, and I will keep this one as such. So this is anyways a constant, so you need not worry about this. So this is the angular part. Just write this angular part here. So this is the overall wave function for 3D xy orbital. It has r square term, e power minus r by 3 a naught term, then sin square theta sin 2 phi term. Sin square theta sin 2 phi will arise for dxy orbital. Is this clear? Any doubt? Listen, some
3D,
hydrogen,
sir.
they are asking which orbital is this.
3D. N is equal to 3, L is equal to 2, sir.
That's all. Very good, ma. Good. That's all. Over. Because listen, this e power minus r, this value gives you n, correct?
Yes, sir.
N. So n equal to 3. N equal 3 means this option get ruled out and this option get ruled out, correct? N equal 3. Only these two possibilities are there. Then r power, this r power 2 is given. So r power 2 gives you L value equal to 2. L value 2 means
D orbital.
D. So it should be
D.
3D. It should be 3D.